With linear programming, we are going to take what we've done in the last couple days, put it together, that standard form graphing inequalities, put the two things together just to make sure that we can now use those tools to do this first really major topic in Algebra 2. So you'll see a couple things about this problem. You'll see that there's some x's and y's together on one side, variables on the other, but now you'll see the inequality symbol kind of pop up. And then there's lots of stuff going on. You see a graph, a table, other stuff going on. With this first problem, it might take you just really sitting here and listening to it. Maybe not following along, but just sitting and listening to figure it out. Then I will give you time to pause the video, write it all down, but I recommend just listening to begin. So let's look at the question. What is it asking us? It says, what values of x and y maximize p for the objective function p equals 100x plus 40y? With this, let's figure out what each of these things mean. So values of x that maximize. Well, we know maximize means get bigger. We are actually going to search for the biggest p. P, we might think profit. This process of linear programming is used mostly by businessmen or businesswomen, and they use it in the business world to try to figure out how can they maximize profit or how can they minimize costs. And so this objective function is the function of what they're trying to do. So they're trying to make profit, and it says, this is how I make profit. That maybe they're selling a couple different types of items. This is the amount of profit they make on each. And how can they maximize this? How can they make it the biggest? And so these constraints are the limitations. These might be production constraints that they say, if I'm making these two things, I only have so much of this item you would need. And then, if I produce it this way, well, then I can get this item. With this here, these are just constraints that say these are limitations I have. So we're going to graph the limitations and then figure out what's the way to kind of handle those limitations the best so that this profit gets maximized. So step one is going to be to graph the constraints. So let's write out some steps maybe here to help us out. Step one is graph the constraints. So to graph the constraints, we're going to lean on the cover-up method we learned a little bit ago, and then the inequality stuff. So the cover-up method here would say, cover up to find y, we find the intercept. So finding the y-intercept, I see the y-intercept would be 8. So a y-intercept of 8. Now I'll cover up the x's. The x-intercept in this case is also 8. And then our job is going to be you're going to want some kind of straight edge, and you're going to want to connect these. Now you're going to want to make sure that as you connect these, we're getting straight lines because we want to catch as many nice grid mark answers as we can. So when I connect these here, and I'm graphing this, I have nice grid intersections all of this way across. So this is why we're using a straight edge, to get all of those points. So first equation, check. Second equation, let's do this. Cover up x, see the y-intercept is 10. Cover up the y's, I see then the x-intercept is going to be 5. So as I'm graphing this again, I want to make sure I'm seeing some nice grid marks. But if you look here, here's a point of intersection that it's crossing at some nice grid marks. So that's good news. We're actually going to want intersection points So make sure I'm getting a straight edge, getting that nice intersection point. That's actually going to be really helpful. Now, these ones, horizontal vertical lines, x equals 0, y equals 0, those are going to actually be really, really helpful for you because it's saying x, all the x have to be bigger than 0. I can't have negative x's. We know that this is vertical and that the y's are horizontal. So this tells you that you've got something vertical at 0 and you've got something horizontal at 0. And so you've got 4 rows to your constraints. You're going to need 4 different lines as you go through with this. So that's step 1, is just to graph each of the constraints. Step 2 then is going to be to identify the feasible region. So what is this feasible region? Well, when we graphed these, we looked at what the overlapping region is, and the feasible region is really just that. It is the overlapping region. That where these things overlap, that is where, when we put all of our limitations together, how we can say this is what our business can feasibly do or what it can actually do. So to figure that out, we got to figure out in these middle sections, which of these is the one that matters? We're never going to be out here. It's always going to be a trapped region. So if I look at this, I got to say, with these diagonal lines, I got to figure out, is it region 1, 2, or 3? Is it this top one, the middle one, or the right one? So I'm going to look at these. The diagonal lines are really what's going to be helpful for you. It says less than, less than. So if we remember, less than is below. So if I want to be below this line and below this line, then I got to say, is it 1, 2, or 3 that's going to be below? Well, here, if I am up in this region right here, I'm only below this line, but I'm above this one, so that doesn't work. If I'm in this region, I'm below this line now, but I went above this one. If I'm in this big open region here, I am underneath this line and I'm underneath this line. So because I'm below both, this is my feasible region. You will want to shade the feasible region. So maybe on your steps, you want to say identify the feasible region and shade it. Step 3 then would be identify the vertices. So I said that we really like the intersection points. So these vertices actually are the intersection points, but they are the intersection points of your feasible region. So these vertices are kind of the outline of the shape that you made. So here I have these. I have the point here, 0, 0. That's one of them. Up here, I have 0, 8. Out here, in this corner, I have 5, 0. And then this one right here is 2, 6. So now we've identified them. Then, step 4 would be to plug the vertices into the objective function. So you'll see you've got the objective function here. It labeled the objective function this. Here it's in the middle. So we are going to take our vertices and plug x in the x spot and y in the y spot. So I'm going to plug in 0 for x, 0 for y, and figure out what is it that I have. Well, 100 times 0 is 0. 40 times 0 is 0. So 0 plus 0 is 0. Then we'll go to the next vertex. So I'm going to plug in 0 for x, but now I'm going to put in 8 for y. So 100 plus 0, 0, but 40 times 8 is 320. So I'm going to get a profit here of 320. Then I'll put in 5 for x on this one, 0 for y. Well, 100 times 5, 500. 40 times 0 is 0, brings up a total of 500. Then I will put in 2